Okay, let's take a look at 7a on page 467 because these are the ones I want you to try today. So the question wants you to find the equilibrium force, the force that'll make the vector sum equal to 0. So to do that, you need to find the resultant of the forces that you're given. So in 7a, you're given two forces. One is 154 newtons, east 22 degrees south. So draw it. Here's my east, this way is south. 22 degrees means it's going like this, where this angle right here is 22 degrees. Put an arrowhead, and this is 154 newtons. This is F1. F2 is west 74 degrees north, so it's up here. Okay, so this is F2. It's 203 newtons. West north, this is my angle in here, 74 degrees. Okay, so once you have those drawn, then the first step is to find the components of each of these. So you're going to have an F1x and an F1y, and you're going to have an F2x and an F2y. So then you just use sine and cos again to find them. So if we look at F1, F1x is on the adjacent side, so that's cosine. So it's going to be, again, cosine of 22 is equal to F1x over 154 newtons. So F1x is going to equal 154 newtons cos of 22. Whereas the sine of 22 should give me F1y over 154 newtons. So F1y is going to equal 154 newtons sine of 22. Okay, so now we can punch these in our calculator. 154 times the cos of 22 gives me an F1x of 142.786 newtons, and that's going east. Okay, whereas F1y is 154 times the sine of 22, so that's 57.689 newtons, and that's going south. Okay, so I have my x and y component of my first one. I'm now going to do exactly the same thing for my second one. I take a look at the x. Again, it's the adjacent side, so it's the cos. So hopefully you're okay if I skip a step and I do F2x, then should just be equal to 203 newtons cos of 74. So I've skipped that first step because I've rearranged it. And F2y should be 203 newtons sine of 74 because it's the opposite side. So now I can punch these in my calculator. So 203 times the cos of 74 gives me 55.954 newtons, and that is west. And now I'm going to do the same thing in the y. So 203 times the sine of 74, and I get 195.136 newtons, and that is north. So I now have my x and y components. So now I add them up. I do the sum of the forces in the x, and I do the sum of the forces in the y. Okay? And notice that they're in opposite directions, so I said add them up, but I'm really going to have to subtract. And I'm going to start with the y because I have the 195 in my calculator. It's going north, so I'm then going to subtract the y component up top that was going south, and I end up getting 137.447 newtons. The north side's bigger. It's north. Okay, and now, again, I have an east and west, so again, I'm going to have to subtract. So I take my 142, I subtract the 55, I get 86.832 newtons. The east is bigger, so I write east. So now I can draw my new resultant. I have going to the east a vector that is 86.832 newtons, going to the north a longer vector, one that's 137.447 newtons, and then this will be my F net, okay, my resultant. So I can find it, and I can find the angle. So to find it, I square, I add it to the 137 squared, I take the square root, and I get an F net of 162.577 newtons. Now I need to find the angle, and of course we're going to do square brackets. When we get the angle, it'll be east something north. Alright, so for my angle, opposite was 137, and then divided by adjacent, which, oops, sorry, try that again. 137 divided by the adjacent, the 86, and then it's going to be inverse tan, and so I get 57.72 degrees. Yeah, so maybe I should have said here. I did tan theta, which we know is opposite over adjacent to get that angle. Okay, now that's my F net, but the question wanted the equilibrium, FEQ. And by definition, from grade 11, the equilibrium is a force that is equal to the resultant, but opposite in direction. So once you have your resultant, the equilibrium is really easy. Opposite east is west. The angle stays exactly the same. Opposite north is south, and you are done. Okay, so that's what it wants you to do for the rest of number 7 and number 8. Number 9's a little bit trickier. Okay, number 9, and I think I might have a couple more minutes left on this 10 minutes. Number 9, you have a sign. No, it's a stoplight, I guess, hanging down, and you have 2 cables supporting it. So, and these angles for the cables are the same. So it's 12 degrees up here, which means it's 12 degrees down here. Okay, so there's an FT in each of these cables. But because the angles are identical, both FT will be exactly the same. And this is FG going down. So you're going to break your FTs up into components. There'll be an FT1X and an FT1Y and an FT2X and an FT2Y. This stop sign is, or stoplight is not moving, we hope, which means the sum of the forces has to equal 0. Okay? So sum of the forces in the x should equal 0, so that means FT1x should equal FT2x. And clearly they do. Okay? In the y direction, though, sum of the forces in the y, it means FT1y plus FT2y minus FG should equal 0. These guys are the same. Okay, if you don't believe me, go back to the x. FT1x minus FT2x has to equal 0, which means FT1 cos of 12 has to equal FT2 cos of 12, so FT1 must equal FT2. So over here, this is like having 2FT, and the y component would be sine theta. Okay, minus FG equals 0. Now solve for FT. Okay, good luck. We'll see you tomorrow.